Hello, hello, hello. Hello, everyone. Am I audible? क्या मैं audible हूँ सभी को?
Recording in progress.
Okay. Am I audible? Just a minute. Just a minute. Okay. Am I audible or visible? There is a screen related to your notebook. This is a screen. Am I properly audible or visible to everyone? Please reply. Am I audible or visible to everyone? You can just also you can just you can type, or also you can write a message, or as well as you can reply with the voice message also. So we are talking about the syllabus. We have a small discussion about the syllabus in your last session. So we were discussing about your syllabus. Now your first subject is network theory. Your first subject will be network theory, where we are going to talk about the electrical circuits and its element, Kirchhoff law, mass and node analysis. Basically, these are the topics. First of all, I am going to deal with this topic. So before starting this topic, our aim is to identify what we are going to done in electrical engineering, what are our aims. So after that we are starting our session. Am I audible properly? Please reply if am I audible or not. In your chat section you can reply. Hello. Hello everyone. Am I audible or visible to everyone? You can hear me properly? Okay. So before we are going to start a small discussion related to your subject, mm, related to your subject or your syllabus, the first subject we are going to deal with the electrical circuit. In this, today we are going to discuss the electric circuit element, Kirchhoff law. Before going to discuss the Kirchhoff law, we are going to deal with some other parameters like voltage, current, energy, power, like this. So our first subject become electric circuit. Name of the subject is electric circuit. Name of subject is electric circuit. You can simply you can reply by typing the message also, or you can directly reply by voice. You can directly start the conversation by having voice chat also. So name of the subject is electric circuit. Electric circuit. Now anyone, if you have any idea related to the electric circuit, why we are using or what we are doing in electric circuit, or in electrical engineering, what we are going to achieve, our aim is, anyone have any idea about what we are our aim is, or what we are doing in electrical engineering? Anyone, please reply. What we are our aim in electrical engineering basically deals with the power. If we are talking about the aim, it is basically deals with the power or efficiency. It deals with the power or efficiency. Efficiency. Basically, we are talking about the efficiency, or if we are talking about the efficiency, that is the relation of output to the input. If we are talking about the efficiency, efficiency means output power to the input power. Input power. First of all, we are going to deal with our aim. What are our aims? So first of all, any engineer have a simple aim is to maximize its efficiency, and the formula of efficiency is output power to the input power. The notation of efficiency is neta. Neta is represented by output. Wait. Output power to the input power. Now, if we are going to deal with the efficiency, first of all, in electrical circuit, we are dealing with, the circuit parameter. Before going to the circuit parameters like current, voltage parameter, I'm just introduce the aim, or the parameter called the source. A simple parameter which is known as source. Anyone can define the source. What is source? Anyone can define the source? Those element those element those element which are capable to deliver the power the power to the load load is known as source. And what become load? Anyone can define the load? Don't think that what if I was wrong, what if I become wrong, what if I become right. Don't think so much. Just reply what. Just when I am asking about the different questions, just simple you can reply what you have any idea. If you have any idea, then simply you can reply, sir, this is source and this one is sink, and all this. Anything consuming the power. Very good. Karanjit, very good. It means anything, those element, we can define the load is, it is also known as sink or load. Anything that consume, anything or हम लोग, just a minute. Those element which consume the power is become load, or we can say that becomes sink. For an example, if we are talking about the load, that is resistor, inductor, sometime it becomes sink, sometime it becomes source. But properly, if have any proper idea about the sink, that is resistor. And in example, what are the sources? For example, battery. Battery is a type of source. Battery is a type of source. Now, our main aim of an electrical engineer. Electrical engineer. Our main aim is to deliver the power from source to sink. Suppose this one is your source. Let us suppose this one is your source. And a far distance, a far distance, let us suppose this is your sink, or you can say that your load segment, where you have to deliver your power from source to sink, from source to sink. This can be delivered by using either electric circuit. If we are going to deliver this power from source to sink, then we are using a medium is known as electric circuit. We are using this medium is known as electric circuit. So we are going to deal with this electric circuit. In this chapter, we are going to deal with this electric circuit. How much power we are going to deliver, how much amount of losses are there, how to get maximize its efficiency. This all the parameter we are going to deal with this subject, electrical circuit theory. This subject deal with how much power get transfer from source to sink, how much losses will occur while transferring the power from source to sink, or what are the topologies we are using while transferring the power from source to sinks is defined by this electric circuit. Is there any confusion, any doubt regarding to this topic? That is, our power is flow from source to sink, and while having the transferring the power from source to sink, we are having different type of topologies. How many parameters are related to this? How can we minimize our losses and maximize our efficiency? So power will flow from power will flow from flow from flow from source to sink, source to sink, or we can say that source to load with with minimum losses, or we can say that while transferring the power, it should have minimum losses that will improve the efficiency of the system. While transferring the power the power power from source to sink, it should have it should have minimum loss. Therefore the efficiency of the system, the efficiency of system become maximum. That's why we are learning about the circuit theory. Circuit theory will deal all this parameter, like how to maximize our efficiency, how to minimize our loss. Is there any confusion? Karanjit, PH, Akhtar, is there any confusion related to this topic? That is, we are going to transfer the power from source to load, and while having the transferring the power from source to load, we have to minimize our losses and maximize our efficiency. The formula of efficiency is output upon input. Output upon input. It is simply the ratio of output to power to the input power. Now, if the efficiency, you can rewrite this formula of efficiency in different manner, like output plus losses. if we are going to remove these losses or minimize these losses, then efficiency become maximum. If losses become minimum, then efficiency become maximum. Or if losses become minimized, then efficiency become increases its value. If losses become minimum, then efficiency become maximum, because this whole denominator factor become minimum, then efficiency become increases. So in this chapter we are going to deal all these parameter. Before going to deal all this parameter, first of all we are going to differentiate between or we can say that difference between network and electric circuit. So simply we can say that what is electric network, what is an electric network, what is an electric network, or and electric circuit. Is there any idea what is the main difference between electric network and electric circuit? Anyone? What is the main difference between electric network and electric circuit? Anyone? Don't hesitate while answering the question. Don't hesitate. Don't hesitate. First of all, I am going to describe about electric network. Circuit means with the closed path. Okay. Okay. And what about the network? And what about the network? And what about the network? Is electric circuit can become a network or not? Is electric circuit become a network or not? Karanjit, is electric circuit become electrical network or not? Okay, let me let me let me explain. Let us suppose if we are going to deal with the parameters like network may be combination of element. Very good, very good. It is not necessary, it should be a closed path. Very good. Now, if we are going to say that, let us suppose this is your n voltage source V of S, and this one is your resistor, and this one is your inductor. There is an closed path. There is an closed path RL. While having this closed path, there is an closed circuit that will allow to flow the current I. This is an electrical circuit. This is an electrical circuit. This is an electric circuit. But what if I'm going to tell you that I have a different component like inductor? This one is your resistor. This one is your capacitor, as well as I have a battery source also, which are connected through this network RLC, and this one is your voltage source. This network, this component, these components are connected at a node and don't have any closed path. They are simply known as network. They are simply known as network. Means they are inactivated. They don't have any closed loop. They don't have any closed loop. Any closed loop. If they don't have any closed loop, then there is a no provision for the current through this network. So this become a network, not an electric circuit. If I'm going to tell you, please identify this network. I'm asking, please identify either it is a network or electric circuit. This one is your resistor, this one is your capacitor, and this one is your inductor. They are close, they are having a closed path with a resistance R, with a capacitance C, and inductance L. Is there any Please tell me, this is a electric network or electric circuit? This is an electric network or electric circuit? Electric circuit. Sir, simply you can say that if you have a voltage source and having a current through this closed network, that is current I, this will flow in this closed network, then this one is a electric circuit. Very good. This one become a electric circuit. It is not, it is also an electric network. It means every electric network, note, every electric network, every electric network can't be an electric circuit. Electric circuit. But every electric circuit, electric circuit can be a network. So what is definition of network? Network is network can simply defined as network is simply defined as the interconnection between interconnection of electrical component, electrical elements either in a closed loop, or in open circuit, or in open circuited. Through Venn diagram, we can easily understand Venn diagram. Every electrical network cannot be an electric circuit. If we are going to represent this is an electrical network, then you can say that, sir, if this is an electrical network, then every electrical network cannot be an electrical circuit. Only those network can be electrical circuit which have closed loop. So this is electrical circuit, and this one is electrical network. This one become electrical network. So every electrical network can become an electrical circuit, but every electrical circuit is not an electrical network. Hope you are getting my point. Every electrical network can be an electrical circuit. No. But every electrical circuit can be an electrical network. Every electrical circuit can be an electrical network, but every electrical network cannot be an electrical circuit. Only those electrical network which have closed paths that is considered as a electrical circuit. Are you getting my point? Is there any doubt related to this two topic, these two terminologies? Is there any doubt? Electrical network and electrical circuit. Electrical network and electrical circuit. Okay. Now, first of all, while transferring the power, the important parameter is electric charge. Anyone? Please define the electric charge. Electric charge. What is electric charge? Anyone? Please define electric charge. I just want to know that how much you are you can say that I just want to know that is there any you are in that mode or not, you are in that mode of learning electrical engineering or not, just for knowing this. Either I will directly write the properties or definition of all the things. So please define the electric charge. What is an electric charge? How can you define the electric charge? How can you define the electric charge? Try to participate all the candidates which are having live session. Rate of flow of current. No. I'm just asking about the electric charge. I'm not just asking about the electric current. Rate of flow of current. No. Okay. Let me explain. Electric charge is an electrical property. You can say that it is an electrical property. Electrical property. Electrical property of atomic charge is a property of matter in which matter experience very good force in place in an electric field. Okay, very good. Property of which it is an electrical property of the atomic particle of which matter consists. And its unit is coulomb. So we can say that one electron having the value of 1.6 into 10 to the power minus 19 coulomb of charge. This much charge is held by an electron. This is the most basic fundamental quantity of electrical circuit. Now, coulomb is the largest unit. You can say that if a charge Q is defined as, that is, it is defined by Ne, where this is known as quantization of charge. This is known as quantization of charge. This will define the charge Q having the integral multiple with the electrons. That is, n is equals to integer. N should be integer. That is, it should be either 1, 2, 3, 4, ... and all this. If we are going to know about this one is known as electron having the value of 1.6 into 10 to the power 19 coulomb. So if you are having 1 coulomb of charge, how much electron you are going to gather to how much electron can combine to form a 1 coulomb of charge? You can say that how many electrons contribute towards 1 coulomb of charge. So for 1 coulomb of charge, you can say that is Q is equals to Ne. The charge defined by Q is equals to Nv. It may be a positive charge, it may be a negative charge. If it is a positive charge, then it should be written like this. If it is a positive charge, then it should be written like this. And if it is a negative charge, it should be written like this, minus of Ne. Now, for 1 coulomb of charge, you can substitute this value of 1 coulomb here. Now, simply you can say that either it will be a positive charge or it will be a negative charge. Then it will be a integer. That is 1.6 into 10 to the power minus 19 coulomb. So the total number of charge contributed for 1 coulomb is 1 upon this much. 1 upon this much, 1.6 into 10 to the power minus 19. This will nearly equals to 6.24 into 10 to the power 18 electrons. If we are going to contribute or collect 6.24 into 10 to the power 18 electrons together, then it become a 1 coulomb of charge. This is known as quantization. This is known as quantization of charge. This is called the, if you are going to collect these electrons together, then it become a 1 coulomb of charge. Or you can say that for 1 coulomb of charge you are having this much electron, then you can say that I have 1 coulomb of charge. This property is known as quantization. This property is known as quantization. Now if uh, I'm telling about the charge, then you can say that charge have basic quantities like this. Property of charge. Property of charge. Let us suppose that if a body, properties of charge. Properties of charge. What are the properties of charge? Let us suppose if a body which have equal number of positive charge and negative charge. Let us suppose equal number of positive and negative charge, then net charge on body become, if equal number of positive charge, that is plus q and minus q, then net charge become 0. This body is neutral body. This body is neutral body. What if anyhow if, or you can say that charge is defined by the number of electron present in the body plus number of proton present in the body. Number of electron plus number of proton present in the body. It is defined by the charge. If Na and Nb are equal, where Na kya? Where Na is equals to number of electrons present in body. How many number of electrons present in a body? Nb is equals to number of protons present in a body. Now what if I'm going to ask you, what if the first case, if Na is equals to Nb, if Na is equals to Nb, then body is neutral charge or uncharged. Just simply you can say that, sir, if electron have minus 1.6 into 10 to the power minus 19 coulomb of charge, then proton have 1.6 into 10 to the power minus 19 coulomb of charge. Simply both the value have same magnitude but different sign or different polarity. Now if both have the same number of electron and the same number of proton, now you can say that if both have same number of electron and proton, then net charge, that is q, is equals to minus 1.6 into 10 to the power 19 plus 1.6 into 10 to the power 19, that is q is equals to 0. This is neutral body. Neutral body. Or you can say that uncharged body. You can say that uncharged body. What if I am asking, what if Na is greater than, Nb, then what? If Na is greater than Nb, then you can say that if Na is greater than Nb, that is this charge become negative, because then Na is greater than Nb, it means that this body have maximum number of electron rather than proton. This body is negatively charged body. what if I'm just having different case if Na is less than Nb. Now what happened? Q is positive. It means positively charged body. So charge doesn't means that you have only electron. Yes, sure. After the class, you can get the PDF note which is written on this screen. So after having charge doesn't means you are having any electron. Charge means how much electron. It is simply, you can say that deficiency and excess of electron is defined as a charge. So first of all, charge is defined as, doesn't mean, charge doesn't means an electron. Charge doesn't means an electron. How can you define the charge? Charge is a charge on a body. Charge on a body is simply defined as the the deficiency or excess of electrons. This is simply define the charge. Hopefully you are getting my point. So first of all, before discussing the property of charge, you should know about the charge. It is simply, charge is a deficiency or excess of electron on a body is known as charge. It may be 2 coulomb charge, it may be 4 coulomb charge. It is simply the counting, simply the excess and deficiency of electron, it become a charge. Now the first property is determined by, charge is conserved. Charge is conserved in nature. It means what? It means charge can neither be created nor be destroyed. Charge can neither be created nor be destroyed. It can only transfer from one body to the another body. It can only transfer from one body to the another body. This is also known as law of conservation of charge. This is also known as law of conservation of charge. Now there is also an important property. There is also an important property, that is, if a positive charge is placed, then it will radiate, or it will radiate an electric field. It will radiate an electric field from the surface which is perpendicular to the perpendicular. It means, let us suppose if you are having a charge, Let us suppose if you are having a charge plus q. Let us suppose this one is your charge having a plus q, any quantity. It may 10 coulomb, 5 coulomb, whatever it is. Let's say plus q charge. It will radiate an electric field from outward, from this surface. It will radiate an electric field outward from this surface, outward from this surface, outward from this surface, outward from this surface, while having the 90-degree with the surface. While having 90-degree of angle with the surface. 90-degree of angle with the surface. Important property, it should be known to you. This is an electric field which are radiated from this electric charge. Now, what if a negative charge? What if you can say that excess of electron? Excess of electron. It means if a negative charge, then electric field lines are conserved towards this charge. Means electric field lines are electric field lines are moving towards this charge while having 90-degree towards this surface. 90-degree of angle with this surface. This is an electric field lines. Electric field lines. Now, the third property is, what if a positive or negative charge? What if a positive or negative charge? The third property. Third one is, if an electric field is moving in this direction, an electric field is moving in this direction, and a positive charge is placed in this direction, then it will experience a force. It will experience a force in the direction of electric field. If the direction of electric field is in this direction, then a force is experienced on this charge in the direction of electric field. And this force, and also what if a negative charge is placed in the direction of what if a negative charge is placed then the direction of force experience on this charge, it become negative. The magnitude will remain same. The magnitude is determined by Coulomb's law. F is equals to 1 by 4 pi epsilon 0 Q1 Q2 upon R square. This is given by Coulomb's law. It states that the force experienced by a charge due to the electric field or due to any charge is given by this. If two charges are having same magnitude, then you can say that if this one is your positive charge and this one is also your positive charge, then they are experiencing a ripple forces. They are experiencing a ripple forces in this direction, which is given by F. And if they are opposite in nature, they are experiencing a attraction force. They are experiencing a attraction force. They are moving towards each other. That is the force F. Or another case, what if both are having negative polarity? Again, they are experiencing a ripple forces. that is the force F. The force F. So the magnitude of force F is given by Coulomb's law. The magnitude of force F is given by Coulomb's law. And here, if we are going to calculate the force, that is F, due to the electric field, F is equals to E into Q. Simply you can say that, and you can determine the force. This is the Coulomb's law. Coulomb's law. So Coulomb's law, Coulomb's law is directly proportional to the product of the charges. Force is directly proportional to the product of their magnitude, and force is inversely proportional to the square of the distance between them. Let us suppose the distance between them is r. If the distance between them is r, so simply you can say that this is the Coulomb's law. And if, just wait, the property is third property is like charges charges are repelled to each other and unlike are attracts. And the magnitude of this force is given by 1 by 4 pi epsilon 0 q1 q2 upon r square. Is there any confusion related to this topic, the property of the charges? First, second, and I think this one is the third and this one is the fourth. This one is third and this one is the fourth. Is there any confusion, any doubt related to this topic about the charge? Charge simply the basic fundamental quantity that contribute in the electric conduction, chemical property as well as mechanical property. So basically property of charges are simply, you can say that the first charge can neither be created nor be destroyed, it can only transfer from one body to the another body, law of conservation of charge. Secondly, if a positive charge is placed, then it will radiate an electric field outward from this surface, and if a negative charge, then it will absorb the electric field lines into the it will absorb the electric field lines from the surface which is perpendicular to the surface. Now if a charge is placed in electric field lines, then it will experience a force in the direction of electric field, and if a negative charge is placed in the electric field lines, then it will experience a force which is opposite to the direction of electric field lines, and the force is given by E into Q. Simply, if a like charges are placed, then it will experience a repel force, and if unlike charges are placed, then it will experience a attraction force. So negative charge, this one is negative charge and this one is also negative charge, then they are experiencing a repel force, repulsion. This one is attraction. This one is repulsion. So simply these are the property of charges. If anyone have any doubt, they can simply ask me. You can simply ask me. Should we proceed? It is not compulsory that you have to type your query. You can simply, by having voice chat, you can easily ask anything related to the concept. Sir, for third property. Which one? This one. Let me explain. The third one is, uh, let us let us assume that for third property, let us assume that there is a positive charge. If it is a positive charge, then electric field lines are emerging from this surface. Is it right? Is it clear? Electric field lines are emerging from this surface. Emerging from this surface. Emerging from this surface, which is perpendicular to the surface of the charge. Electric field lines are like this. If this electric field lines are moving towards infinite, this will look like a parallel charge, parallel electric field lines. This will look like a parallel electric field lines E. What if a positive charge is placed? Then this charge and this charge having the same property. This positive charge and positive charge having the same property. Just wait. Just a minute. Just a minute. Just a minute. Now, let us suppose, what if this is a positive charge and this one is also a positive charge? If this charge emerges an electric field lines, and let us suppose it is placed at the infinite, very, very small, placed at infinite. Infinite. Now, electric field lines are emerges from this, and if we are going to observe this, they are look like parallel from the infinity. They are look like parallel from the infinity. Now, these electric field lines are moving parallel to itself. Now, I'm asking, what if this charge is placed in the path of electric field lines? This will experience a repulsion force, because at infinite, due to this electric field is produced by this charge which is placed at the infinite. So this charge and this charge experience a force of repulsion. This charge experience a force of repulsion. So if I'm asking about like this, if an electric field lines are moving in this direction and a positive charge is placed, this charge experience a force in the direction of electric field, because at infinite there is a source of this electric field which is a positive charge, and this positive charge and this positive charge are repelled to each other. Therefore we can say that if a positive charge is placed in an electric field lines, this will experience a force in the direction of electric field lines. Is it clear? Is it clear? Karanjit, is it clear? In a similar manner, if an electric field lines are moving in this direction and negative charge is placed, then it will experience a force of attraction. So we can simply say that if electric field lines are moving in this direction, the force of attraction or the force experienced by this negative charge is opposite to the direction of electric field. Just the extension of force of attraction and repulsion property. Force of attraction and repulsion property. Simply. So from now onward, you can simply say that if an electric field lines are moving in this direction and a positive charge is placed, then it will experience a force in the direction of electric field. And if a negative charge is placed in the electric field lines, in the direction of electric field line, or sorry, if a negative charge is placed in electric field lines, it will experience a force opposite to the direction of electric field lines. Now, this will uh, this will elaborate in, I think, in EMFT. There is a chapter in EMFT the property, the static property of electric charge. This will elaborate uh, different property of electric charges, different property of electric charges that will elaborate at that time. Now we are going to move towards the atomic structure, atomic structure of atomic structure atomic structure. Let us suppose, let us suppose this is calcium, or you can say that, let's say simply, we are having proton, silicon, aluminum, magnesium, sodium. Let us suppose sodium. So atomic structure, this one is your nucleus. This one is your nucleus. Any, sorry, nuclear. Now, in this nucleus, there is a proton and neutron. And simply you can say that inside the nucleus, proton is positively charged, neutron has neutral, and there is an orbit which is known as shell. There is an orbit which is known as shell, and this cell have basically different level of energies. This cell have basically different level of energies, and each cell have different electrons. Let's say this one is K, L, and again the another is M. K, L, and M. Different cells. The electron is filled in different cells is given by 2 to the power n square. If n is equals to 1, that is cell 1, then you can say that k is equals to 2 into 1 to the power 2, that is equals to 2 electrons are filled in the cell K. Now what about the second cell? N is equals to 2. Then cell number L have 2 to the power 2, 2 into 2 to the power 2, that is equals to 4. 2 into 4, that is equals to 8. It means L have 8 electrons. L have 8 electrons. What if cell number 3, KLM, M is equals to 2 into 3 to the power 2, that is 2 into 9, 9 to 18. It means M have 18 electrons. So consider this one. I am going to increase this value. You have found that there is 8 electron, and this one is 8 electron, and this one is 1 electron. Outermost have 1 electron. So this rule is known as octet rule. Octet rule. Octet rule shows that for the stability of electron, for the stability of atom, the outermost cell, most shell should have 8 electron. So if I'm asking about if it is a positive charge, please reply. I'm asking about, let us suppose this is a nucleus which have proton as well as neutron, and they are and these are the orbits where electrons are placed. Let us suppose this is radius r1. Please do not write. This is radius r1, This one is radius R2 and this one is radius R3. At different radius, there are the position of each electron in different cell. Position of each electron in different cell. We know that by Coulomb's law. Coulomb's law. Coulomb's law states that if the radius increases, then force will decreases. What if radius decreases? Radius decreases, then force will increases. So I'm asking about, let's say, the force experienced by this electron is F1, this electron is F2, and this electron is F3. Which force have the larger magnitude? Which force have the larger magnitude? F1, F2, or F3? F1, F2, or F3? Which force have the larger magnitude? F1, F2, or F3? F1, F2, or F3? Which force have the larger magnitude? F1, F2, or F3? Sir, R1 is less than R2, which is less than R3. If radius increases, then force will decreases. If radius increases, the order of force become this. The order of force become this. So this electron, which one? This electron, the first orbital shell electron have the larger magnitude of force. So you can easily remove this electron from the outermost shell. This electron become loosely bounded electron. This will used in the conduction. This will used in the conduction. While having a conductor, this will participate in the conduction. This will participate in the conduction because the force of attraction on this electron is much smaller than F1. So you can easily remove this electron from the outermost cell. Outermost cell. You can easily remove this electron from the outermost cell. So this electron is participate in the conduction process. Now we are going to talk about the voltages, then we are going to talk about the current, and then we are going to talk about the energy and power. So we are going to deal with three topics, uh, one after the another. Now, first of all, I am going to talk about the voltages. Voltages. Anyone can define the voltage? Anyone can define the voltage, or you can say that electric potential. Anyone can define the voltage or electric potential? What is a voltage and electric potential? Okay, let us assume that in very infinite small test charge particle. This is test charge. Sorry, very. Let us suppose a charge plus q is placed, which is fixed. Now let us suppose that a very infinite small test charge particle, a very infinite small test charge particle duq is placed at infinite. Yeah, at a position A. At position A. Infinite small test charge particle is placed at this position. Let us suppose this is also a let us suppose this is also a positive charge. Which one is test charge particle? Now, what if I just want to move this charge particle from infinity to at any position? Test charge particle dq. I just want to move this charge particle from this position to this position. I just want to move this charge particle from this position to this position. This position, at any position. So both charges are positive in nature. So if both charges are positive in nature, they are experiencing force of repulsion or attraction. What they are experiencing? Force of attraction or repulsion? What they are experiencing? Force of attraction or repulsion. Both charges are positive charge. Both charges are positive charge. Sorry, I think.
Recording in progress.
Sorry. I think there is there is an issue related. Okay. Now, tell me one thing. Am I audible? Audible and visible? Everything fine? Am I audible or visible to everyone? Yes, okay. So, I'm asking, what if both charges are positive in nature? This is fixed charge and this one is test charge particle, which is tiny, very small, placed at point A. If I have to move this charge particle from this position to at any position in this direction, so they are experiencing the force of attraction or repulsion. What they are experiencing? If I am moving this this tiny small test charge particle experiencing force of attraction or repulsion, because both charges are positive, then which force this small tiny test charge particle experience? Force of attraction or repulsion? Just simply reply this question. This test charge particle experiencing force of attraction or repulsion? Both have same charge but same. Okay. Now, this small tiny test charge particle experience the force of repulsion. While having repulsion, a force is experiencing this. Due to this test charge particle, it will move to away from this line of action. But I'm applying energy to move this test charge particle from this position to this position. While applying this force or energy, I am doing a work done, and this rate of work done is known as voltage. Rate of work done is known as voltage. That is dw. Due to this force of repulsion, I am doing a work in this direction by moving this discharge particle from position A to position B. A small work done is done to move a small infinitely small test charge particle from position A to position B is known as voltage. It means to move a small test charge particle test charge particle from infinity to from infinity to that position, 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 the amount of work done will the amount of work done that is experienced or applied, that is applied, is known as electric potential, electric potential, electric potential, which is denoted by V. So V is equals to dW by dQ. The unit of voltage, unit of voltage. So V is equals to dW by dQ, or V is equals to dW, work done. Work done is measured in joule and charge is measured in coulomb. So unit is joule per coulomb, joule per coulomb, or it is also known as, it is also called volt. It is also known as volt. So the unit of test charge the unit of voltage is volt or also joule per coulomb. Now this is denoted by, what if, again I am asking another question, what if this test charge particle, consider I am moving this at position C. Let's say the work done to move this test charge particle at position B is WB, and moving to this test charge particle, the work done required is WC. Which one is greater, WB or WC? Which one is greater, WB or WC? Which one is greater, WB or WC? Which have larger amount of energy is required? Which have larger amount of energy is required? Very good. WC have the larger amount of energy is required. So WC, the work done to move the test charge particle from position A to position C is greater than WC is greater than WB. Therefore, the test charge particle is dq. So we can say that Vc is equals to dwc upon dq, and what? Vb is equals to dwb upon dq. You can simply say that, sir, they are they are difference in energies. Basically, they are different with their energies. The amount of energy required to move the charge from position from position A to B and C, they are basically the amount of energy. The test charge particle in both the cases are same. So we can say that Vc is greater than Vb. So this is denoted by a battery polarity. This one is positive polarity and this one is negative polarity battery. So the voltages is also denoted by this. This is basically represent by VCB. This is potential at C and this one is potential at B. This is represented by VC minus VB. This is known as the battery. This is known as battery. And in this battery, this C is higher potential and this B is at lower potential. This is known as at higher potential. This is become higher potential, and this is become lower potential. This has become lower potential. So basically, now onwards, we are going to study the voltages in this manner. In this manner, they are represented by this. They are represented by this. If a battery is determined by this one, let's say this is potential A and this one is potential B. So this is denoted by VA and this one is denoted by VB. This is at higher potential, and this one is at lower potential. This is one at lower potential. So To determine this, the polarity, to determine the voltages of this battery, we are written like this: VAB. This is given by VA minus VB, or you can say that VAB is nothing but voltage at higher potential minus voltage at lower potential. Simply, VAB is written by voltage at higher potential minus voltage at lower potential. Simple. You can rewrite like this. So now onwards, if a battery is given, let us suppose if a battery is given like this 5 volt, it means what? It means what? If this is potential A and this one is potential B. So the difference between VAB, this is given by VAB. I'm just taking an example to explain this important parameter, important terminology related to the battery. Let us suppose VAB is equals to 5 volt. It means VAB is equals to 5 volt. Or you can say that, sir, VA minus VB is equals to 5 volt. You can say that VA is equals to 5 volt plus VB. It means if we are going to measure the voltage at VA, it will 5 volt more than VB. You have to add 5 volt in VV, then it become VA. So now onwards, this is the relation that will very helpful for determining the concept of power energy in the electrical circuit. I'm asking some question. Please try to reply each question. That will very helpful for your concept building as well as solving the electric circuit in further sessions. So let us suppose I'm asking a question. Let us suppose if VB is equals to 0 volt and VA is equals to 10 volt, determine VAB. Just simply reply the value of VAB. Just simply reply the value of VAB. Just simply reply the value of VAB. Please participate. Please try to participate. WC. Please try to participate. These are the small concept, but they are developing a very they are creating a very vast difference in your concept building. So if we are going to, very good, 10 volt. So we are going to solve this question. So VAB is equals to, I don't have any idea. Okay. Sir, we know that simply VAB means potential at higher voltage minus potential at higher potential minus lower potential, higher potential minus lower potential. 10. Very good. Try only 2 or 3 people are replying. The rest of them are VAB is equals to VA, higher potential VA minus lower potential VB. Now if VAB, we have to determine VAB. Potential of A is 10 volt. Potential of B is 0. Sir, VAB is equals to 10 volt. Don't think that, sir, they are the simple question. Please try to ask another question. Why I'm going to participate in this question? I will participate only gate level or ESE level question. These are the basic question that will ask in gate also. So don't judge. Please try to reply each question. That will very helpful for you. That will develop a basic concept. I'm asking another question. And try to reply. Let us suppose this one is minus 10 volt and this one is VA potential, and VAB is equals to VAB is equals to 100 volt. Determine VA. Determine Determine VA. Determine VA. Try to solve this. Determine VA. Very good. 90. Very good. Only 2 replies are there. Sir, simply you can say that VAB is equals to higher potential minus lower potential. Sir, VAB, the value of VAB is equals to higher potential, the VA, terminal VA, lower potential, terminal VB. Now, VAB is equals to the value of VAB, we have to determine the value of VB minus of 10 volt. Now, VAB, the value of VAB is equals to 100. Now, VA plus 10. So, VA is equals to 90 volts. So, simply you can say that, sir, this is 90 volt. Now, I am going to provide a short trick. You don't have solved all this type of manner. You have to simply say one thing. Simply, you have to learn a simple shortcut that will allow to easily solve all this question. If you are going from negative terminal to positive terminal, then you say that, sir, this is a rise of voltage. Rise of voltage. Simply learn this one. If this one is, if you are going from positive to negative, then you say that this is drop of voltages. This is the drop of voltages. Now, again, this one is, if we are going to negative to positive terminal, then it becomes rise of voltage. Rise of voltage. If we are going from positive to negative, then it becomes drop of voltage. Now, from this concept, from this shortcut that will allow to solve such question in a quick manner. Look like this. Let us suppose if we have minus 20 volt and we have to determine VA, which are VA if VAB is equals to 200 volt. Now, sir, I don't have that much time. I am this one from negative to positive, that is the rise of voltage. Rise of voltage. Voltage. How much? From negative 20 volt to 200 volt. So, negative, I have to rise 200, that will equals to 180 volt. That is 180 volt. So, VA is equals to 180 volt. Simply. Is it clear? Is it clear? Is it clear? Is it clear? Any doubt? Any doubt? You can simply apply this trick. You can easily find every potential, every terminal potential, every node potential easily in further classes while we are solving the node or mesh or KVL or KCL or equivalency of anything that will easily allow to solve this type of questions. Now, let us ask me one tricky question related to this concept. If this one is VA and this one is VB, and if VB is greater than 0, VAB is greater than 0, then which of the following option is are correct? Option A VA, option B this much, option C VA is equals to VB, option number D VA and VB. No. Wait. VA is equals to VB is equals to 0. Tell me, if VAB is greater than 0, so which of the following option, which one is true? Option number A. Very good. Very good. Now, this one is VAB. So you can say that VA minus VB. Okay, sir. Now, if VA, you have to determine either VA or VB. Among VA and VB, if anyone get judged, then another is also get judged on behalf of the one parameter, either VA or VB. Now we can say that, sir, VAB plus VB, VA, this is VB and you have VAB. So this extra factor get added in VB. So you can say that VA is greater than VB. VA is greater than VB. So option number A is correct. Or by trick, you can also say that, sir, this is the rise of voltage. And if this value is greater than 0, then rise of voltage means VA is greater than VB. Now, another question. Another question. Let's make it more difficult. Let's make it more difficult. Let's say this is VA, this terminal is VB, and VAB is less than 0. Then which of the following options are true? VA is less than VB. Option number B, VA is greater than VB. Option number D, VA is equals to VB but not equals to 0. Option number D, C. Let's say this one is C. VA is equals to VB is equals to 0. In this case, now voltage polarity get reversed. Voltage polarity get reversed. Option number A again. Very good. Option number A again, because the value of VAB is negative. Again, I am saying that if we are going to negative to positive, that is the rise of voltage. This rise of voltage is only if VAB is greater than 0. Then this definition is true. But in this case, this definition says that drop of voltage, because VAB is less than 0. It means VA, the potential of VA is less than potential of VB. VB is greater than VA. If you are able to grasp this concept, then you are quite well in solving the another question related to this concept. And try this one. Let us suppose this is minus 20 volt and this one is 200 volt, and this potential you have to determine the potential VA. Determine the potential VA. Determine the potential VA. Karanjit, I think this will be positive positive of 180 degree. 180, sorry. Positive of 180. Try to solve. Try to solve. Try to solve and verify. Try to solve and verify. Okay, let me solve this one. First of all, I am saying that, sir, this one is a rise of voltage. No need to worry about rise of voltage. Okay, if I'm going to rise this voltage with the negative voltage polarity, but actually they are dropping because the VAB is less than 0. It means while having this polarity terminal, this rise of voltage is true for VAB is greater than 0. If VAB is less than 0, it means VA is less than VB. VA is less than VB. And between terminal VA and VB, we have to create a difference of 20 volts. Now, let me solve first of all. Sir, VA minus VB. Now, VA minus VB, the difference is minus 20 volt, which is given on the polarity of the battery. VA, it is to be determined. Now VB is given that 200 volts. Now if VA is equals to, you have to transfer this from right hand to left hand side. You can say that 20 plus 200 volt. Then Karanjit, this will be 180 volt. This will be 180 volt of positive terminal. Now, if you are going to this manner, the rise of minus 20 volt, Nothing to worry about this. You have to take this polarity and you have to add whatever it is given, minus 20. Because you are rising the voltage. Rising means rise means add. Rising means adding the voltage difference, that is minus 20 volt, that is 200 minus 20. 200 minus 20, that is equals to 180 volt. Is it clear? Is it clear? Any doubt? Is it clear? Any doubt related to this concept? Is it clear? Any doubt related to this concept? Any doubt related to this concept? No doubt. No doubt. No doubt. Now, now, if you don't have any doubt, then please reply this one. Please reply this one. Okay. Let us suppose VAB is less than 0. This is terminal VA and this is terminal VB. This is terminal VA and this one is terminal VB, which is equivalent to this, which is equivalent to this. VAB is greater than VBA is greater than 0. Is it true or false? Is it true or false? The representation is true or false? The representation is true or false? The representation is true or false? Okay, let me explain this one. Sir, if this is given that VAB is equals to VA at higher potential, VB at lower potential. Okay, sir. Now it is given that which is less than 0, you can also determine this value by VAB by having the negative terminal, and this one is VA and this one is VB. Now you can eliminate the negative value by reversing the polarity. VB minus VA. Yeah, this one is, if we are going to write this voltage VAB in this manner, here we can write this voltage VBA is equals to, sir, potential at VB minus potential at VA, which is greater than 0. You can say that, sir, VA, which is equals to VB minus VA. Yes, sir, it is clear. Now the both potential, both the battery, it is the name of the battery. It is given by VB minus VA. It is also the VAB is equivalent to VBA, which is equals to VB minus VA. Why it is not true? Both have the same polarity. Both have the same value. VB and VA, VB minus VA, VBA, VB minus VA, both have the same values. Why it is not false? Why it is false? It is true. Sorry. Why it is false? It is true. It is true. They are both equivalent. They are both equivalent to each other. Clear, Karanjit? Akhtar, Khurshid Akhtar. Clear? Are you getting my point? Are you getting my point? Now, this is the depth concept related to the voltage. Now, we are moving towards the Ohm's law. Further moving towards the Ohm's law, I just want to introduce the concept of power. Concept of power. What is power? Anyone? What is power? What is power? Anyone? Don't hesitate to try to explain, try to write, or if you are not able to write, or you don't want to write on the pad, or if you are watching on the laptop, then you can directly reply with the voice message also. Don't hesitate If I am wrong, I am doing the wrong thing, don't think too much. Product of voltage and current. Uh, this definition is too much casual. This definition is too much casual. Try to be explained like an engineer. This definition related to the just look like you are studying in class 10th. You are not in your high school, na? You are engineering student and appearing for A examination. So try to explain like this. You have to face the interview also. Rate of doing work. Very good, very good, very good, very good. Karanjit. Very good. Rate of doing work. Very good. So, okay, very good, very good. Now, it is simply, you can say that it is the what is the rate of the rate of change of the rate of change of energy. It is the rate of change of energy and rate of change of energy. So if we are going to determine the rate of change of energy, the power is determined the rate energy. Rate means differentiation. Rate simply meaning of rate differentiation of anything with respect to time. That become the rate. That is the definition of rate. And what is changing? Energy. Energy is represented by W. So the power is represented by dW by dt. That is the rate of change of energy. So what is the unit of power? Unit of power? Unit of power? Please tell me. Unit of power? Power is determined by joule per second. Joule per second. Is it clear? Or you can say that this one is watt. So power is also determined by this formula. This unit. This unit. You can say that power is equals to, it is measured in joules. This is one is measured in seconds. So easily power is determined by joule per second, or you can say that this is equivalent to watt. This is equivalent to watt. Now what if I'm saying that sir dW by dt? What if I'm simply try to change one thing? Simply try to change one thing, that is what I just want to change. I just want to multiply this dq at numerator as well as in denominator. Now there is a small change dw by dq and dw by dq by dt, and this one is dq by dt. We can say that if dt is replaced this they are interchanged with each other, and dq become dq by dt and dw by dq. So we can say that the power is equals to, have you ever seen this formula? Have you ever seen this formula somewhere? I think this is related to the this is related to the hmm related to which parameter? This will define which parameter? dw by dq. Just before just before just before this questions just before this question, sir, v dw by dq, dw by dq, dw by dq. Sir, basically this is nothing but this is the voltage, and dq by dt, rate change of charge, rate change of charge, this is known as current. So power is also determined by V into I, voltage into current. Power is also determined by voltage into current. So the unit of power is also given by volt ampere, volt ampere or watt. Is it clear? Is it clear? Tell me, bhaiya. Tell me. Are you getting my point? So this is the mathematical expression which are obtained from this expression. Now, important point is concept of power, how to determine the power. Important point, very very important, very very important. Concept of power. Concept of power. What is the concept of power? How can you determine this element absorb the power and this element delivers the power? How can you determine, sir, this is a source and this one is sink? Concept of power or concept of source and sink. Concept of power and concept of source and sink. Concept of power and concept of source and sink. Now, let's say one thing. From today onwards, what you have studied in your academics or in your anywhere, what you have studied doesn't matter. From now onwards, I'm saying that, what I'm going to say that just focus on my words. Just mark on my words. Just remind these words always in your life to determine the power. This concept is very, very, very important. Very, very, very important. Just simply. Let us suppose, this is element X. X may be a resistor, X may be an inductor, X may be a capacitor, X may be a battery, X may be a generator, X may be whatever it is, whatever electrical equipment you know in electrical engineering, that may be a X. Whatever it is, I don't have any idea about X. Whatever it is, I don't have that much interest in X. I know that you this is your X, that not your X which you are thinking about. This is your X. That this is your X with maybe a electrical component. It may be a battery, this may be a inductor, this may be a capacitor, this may be a transistor, this may be a diode, this may be a generator, this may be a motor, whatever it is, I don't have any idea. What I have an idea is the polarity of this X is V. The polarity of this X is V. And the current entering from the positive polarity. Current entering from the positive polarity. Remind it always, while calculating the power, must determine the polarity, must focus on the polarity, must concentrate on the polarity, either the current entering from positive polarity or negative polarity. Mind my words, what I am saying, that the always mind the polarity of the always mind the current entering through which polarity. If current entering from the positive polarity, mark the positive polarity with the voltage. Whatever it is voltage, it may be a 10 volt, it may be a 5 volt, it may be a 20 volt. Whatever it is voltage, that doesn't matter. But mark the polarity. Polarity is positive with the voltage V. Now, multiply. Always take current as a positive value. Always take current as a positive value. This will equals to positive V into I. If the value is positive, then power is, mark my words, power is absorbed. Power is absorbed. Or if power is absorbed, then power is dissipated. Dissipated. Or you can say that power is received. Power is received. Or you can say that power is consumed, absorbed or consumed. If power is consumed, then it is a sink or source. Please reply. If any element if any element consume the power, it is a sink or source. It is a sink or source. If power is consumed, it is a sink or source. If power is consumed by any element, it is sink or source. Sink. Very good, very good, very good. It means if power is positive, then it become a sink. Then it become a sink. Now consider the another factor. Consider the another factor. Another factor is, let's say the polarity get reverse across this element. This one is negative, this one is positive. Polarity get reverse. Mark my words. Always while calculating the power, determine or mind that current polarity, current entering through which polarity. Always mind this. Mind this. In this case, current is entering with the negative polarity. Here, current is entering with the positive polarity. Now, while calculating the power, sir, you have told me that always consider the current as positive. Always consider the current as a positive and the voltage with the negative polarity. Now, if we are going to calculate this power, this becomes negative VI. It means if there is a negative power, negative sign, it means power is delivered. Power is delivered. Power is delivered. If any element delivers the power, it becomes source or sink. If any element delivers the power, it becomes source or sink. It becomes source or sink. It becomes source or sink. Source. Very good. It means this becomes source. This becomes source. This becomes source. So towards today onwards, this concept is very important, very much important for all the subjects related to your electrical engineering. It means if power is positive, it means that element absorb the power, dissipate the power, consume the power. This means it become a sink. Or if power is negative, it means the element delivers the power, it become a source. While calculating the power, always consider the current as a positive. Current always as a positive. And while calculating, be careful either current entering from positive terminal or negative terminal. Through which terminal it is the current is entering, take as terminal as it is, that is positive, and take that terminal as it, that is negative. Calculate the power. If power is positive, then it becomes sink. If power is negative, then it becomes source. Is it clear? Is it clear? This is the concept of power. This is the concept of power. Are you getting my point? Are you getting my point? Now, if you are getting my point, then please allow me to ask one simple question. And the question is, question is very simple. Any element, any element X absorb, any element X have, having the power P is equals to minus 20 watt. 20 watt. It is sink or source. Sink or source. 20 watt. It is sink or source. It is sink or source. Source. Very good. Sir, it becomes sink because it becomes sink. Negative power. Source. It becomes source because it have negative power. So ये source, that is deliver the deliver the power. Now, let me ask one thing. Let me ask one thing. Let me ask one thing. Let us suppose this one is 20 volt and this one is 1 ohm resistor and this one is your 10 volt battery. This one is your 10 volt battery and current I and current 10 amperes delivering from this direction. Calculate the power of battery A and battery B. Battery B. Calculate the power of battery A and battery B. Your options are 200 watt positive minus 100 watt. Option number B, minus 200 watt plus 100 watt. Option number C, minus 200 watt minus 100 watt. Option number D, plus 200 watt plus 100 watt. Option number B. Very good. Very good. Sir, this current will entering from this terminal positive and negative 10 ampere. So we have to calculate the power at battery B. Sir, you have told me that always take current as a positive terminal and battery you should take the polarity of the battery. Current is entering from the positive terminal, that is positive of 10, that is equals to plus 100 watt. Sir, plus 100 watt plus 100 watt. Now I have to determine the battery power of A. Sir, 10 ampere entering from the negative terminal and this one is positive terminal. Now, sir, you have told me that take current as a positive. Now consider the negative terminal, negative of 10. That is equals to, sir, PA is equals to negative of 100 watt. Sorry, 20 volt. 20 volt. That is equals to 200 watt. So it will equals to negative. Negative means source. Source means deliver. Deliver. This one is sink. Sink means absorb. Absorb. This one is battery but absorbing the power. Absorbing the power. This one is also a battery but delivering the power. Delivering the power. So while seeing the battery in the circuit, it doesn't mean that it become always a source. It will decide by the circuit condition. It is also a battery. This one is also a battery, but this one behave like a source. And this battery behave like a sink. Getting my point? It is the circuit condition that determine the which parameters should a source and which parameters should be sink. Which parameters should a source and which parameters should be a sink. Getting my words? While seeing the battery, you cannot say that a battery is always a source. Battery cannot be a source at every time. It is the circuit condition that determine the battery is either source in this condition or sink in this condition. Note, it is the circuit condition that determine the circuit condition determine the 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 element is a source or sink. But a resistor is always behave like a sink. A resistor is always behave like sink. resistor हमेशा always behave like a sink. It is always work like a stick. Are you getting? Are you getting my words? Are you getting my words? Any doubt? Till now we have completed 2 hours class. Any doubt related to this 2 hours class? Related to any concept, related to charge, related to voltage, related to potential, power. Are you getting everything? Everything. This is related to the voltage. This one is related to the charge. Because I'm not going to too much detail in this atomic structure, because we are going to deal this chapter in detail in material science also. So that's why I'm not dealing that much atomic structure in this subject. So we are going to deal atomic structure in material science. There will be, we are definitely discuss the atomic structure. So the main requirement of this chapter is the loosely bounded electron, the outermost shell electron will participate in the conduction process. That will the small concept, that will loosely bounded electron that will liberated from the outermost shell. It is to be determined while having discussing the Ohm's law. That's why I'm telling this concept in this subject also. Now, so we are, before closing the session, the last topic of today class is law of conservation of energy. Law of conservation of energy. Law of conservation of energy. Anyone? Please define the law of conservation of energy. What it states. What it states. Please. Law of conservation of energy. What it states. Please go ahead. Okay, let me tell. Energy can neither be created nor be destroyed, can transfer from one form to the another form. Very good. It states that energy can neither be created nor be destroyed. It can only transfer from one form to the another form. Example: hydropower plant. Hydropower plant. Potential energy to kinetic energy through electrical form of energy. Another example: thermal power plant. Coal heat energy, and again kinetic form of energy, again electrical form of energy. Another example: solar to electrical form of energy. So these are the example. Basically it also states that the summation the algebraic summation of the algebraic sum of power in a circuit at any instant of time, any instant of time is zero. It means summation of power in a closed loop at any instant of time is zero. It means the power delivered should be equals to the power absorbed in a circuit. In a circuit. This is very, very, very important. This is very, very important. Now, on behalf of this concept, I just want to write a question and try to solve this question by your own. Otherwise, I will solve this question in your next session, that is by tomorrow onwards. Find the power of each element. Find the power of each element in the below given circuit. The circuit is look like this. This one is positive of 10 volt, and let us suppose this one is, let's say this one is minus of 2 volt, and consider a 4 ampere of current source. 4 ampere of current source. Take 5 ampere of current source in this direction. 5 ampere of current source in this direction, and take a 6 ampere of current source in this direction. And another, what you are going to consider another thing, that is minus plus of 3 volt in this direction. You have I think, let us try to solve this one. After that, we are try to solve. Consider the power. You have to calculate the power in each element. Sir, if I am going to calculate the power, then I have to determine the current. This one is 6 ampere. Yes, sir. If 5 ampere current source is there, that is this branch will carry the 5 ampere current. So this branch is also carry the 5 ampere current. So if 6 ampere is coming at this node and 5 ampere going towards this branch, then 1 ampere will go with this branch. Is it clear? 1 ampere is going with this branch bypassing this 3 volt source. Now 4 ampere in this branch. At this node, 4 ampere and 5 ampere become 6 ampere of current bypassing this 2 volt source. Okay, sir. Simple. Sorry, 6 name. It is not 6, 5, 4, 9 ampere of current in this branch. Okay, no doubt. Now 9 ampere of current in this branch. If 1 ampere of current is coming from this branch, 1 ampere of current is coming from this branch, then 1 and 9, it becomes 10 ampere of current is moving through this branch, 10 ampere of current, and this will carry the 4 ampere, and this will again carry the 6 ampere. Law of conservation of charge. It means current moving through each branch is conserved. Current moving means the charge is moving through each branch is conserved. Now we have to calculate the power, and while calculation of power, we have to determine the voltage. Let us suppose this is 0 volt, so this is a conductor and this one become the 0 volt. This one become the 0 volt. This one is a rise of voltage. Rise 0 become 0 get rise by the 10 volt, then it become the 10 volt. The higher potential should be positive and lower potential should be negative. Lower potential should be negative. Now, this one is 10 volt, 10 volt. Again, this one is also 10 volt. This terminal should be also 10 volt. Again, negative to positive, that is rise of voltage, rise of 3 volt. It means this one become 13 volt. And 13 volt is higher potential and 10 volt is negative, lower potential. Potential positive doesn't means it have the positive charge. Positive terminal determines the higher potential. It may be a get higher potential of 0.01 volt also. It may be it is also represented by a positive terminal. Positive terminal. In a similar manner, if it is 13 volt, it is represented by positive. This one is 10 volt, it is represented by minus. Now, if it is 13 volt, this is also a conductor. This one is also a conductor. So this one become a 13 volt. 13 is higher potential. 13 volt. This is represented by positive. And this one is 0. 0 is lower potential. This is represented by negative. This one is represented by negative. That is 0 volt. Now, now what? This one is 10 volt. So this terminal is 10 volt. You are going to drop this voltage. You are going to drop this voltage. Drop of 2 volt. That is equals to 8 volt. This one is negative potential and this one is positive potential. This one is positive potential. Again, this one is 8 volt and this one is 0 volt. So 8 volt become higher potential and this one become negative. 0 is lower potential. This one become negative. This one is 13 volt. 13 volt. So it will behave like a positive and this one is 8 volt behave like a negative. Every potential I have marked, every direction of current I have marked. Now you have to calculate the power of 10 volt. Consider 10 ampere entering. Sir, always consider positive. Current should be positive. Entering from positive terminal. Positive terminal. That is 10. 10 into 10. 10 times 100 हो जाएगा. That is 100 watt. P is equals to 100. It means absorb. Absorb. Calculate the power of 2 volt. 2 volt. Sir, current of 9 ampere entering through 8 volt and this one is 10 volt. Sir, 9 ampere. 9 should be positive and current entering from 8. That is 9 8 9 8 is 56. 9 8 are 56 watt. Now, calculate the power through 6 ampere. 6 ampere. Sir, current is 6. Sir, always consider current as positive 6. The voltage current entering 6 ampere through this terminal and this one is negative. Sir, negative of 13 volt. 13. Sir, 13, 78 watt. 78 watt. 78 watt. 72, not 56. 72. Oh, sorry. Sorry. 72. Thank you. Now, यहाँ पे देखो. That is 5 ampere. Sir, 5 ampere of current entering from positive terminal because this is at higher potential and this one is lower potential. Lower potential of how much? 8 volt. 8 volt. Lower potential of 8 volt. Sir, this one, sir, how much? 5 ampere of current of negative potential of 8 volt. नहीं सॉरी, पॉजिटिव है ना, 8 और 5, डिफरेंस नहीं, you have to calculate the difference. 13 minus 8, that is equals to 5. 5 5 are 25 watt. You have to calculate in this manner all the power through each element, all the power through each element. P of 4 ampere, current entering from negative terminal. Okay, how much the potential difference? Potential difference of 8. How much the current? 4, that is minus 32 watt. Now the last one is, I think this one is last, the we have to calculate the power of 3 volt. Sir, current entering of 1 ampere. Sir, current should always positive, 1 ampere, and the potential difference of 3 volt, and current entering from positive terminal 3, that is equals to 3 watt. Consider, add all the three powers, positive powers, and all the negative powers, all the negative powers. Negative are 78 minus 32 and minus 72. Tell me how much negative power are there, and add all the positive power. 100 watt plus 25 watt plus 3 watt. I think 128 watt, this much. And 128. Is there any mistake? 4 फिर 32 negative 3 volt, 13 and 5 ampere, 6 ampere and 13, 6 ampere and 13, 78, 6 ampere and 13 हो गया 78. Is there any calculation mistake? Is there any calculation mistake? I think every calculation is perfect. 5, 8. Okay, if there is any calculation mistake, we will see in the next class, next session. So our main aim is how to calculate the power across the each element, and the power that much power, if power is absorbed this much, this will deliver from any of the sources, any of the sources that will deliver the power. 4 ampere, 4 ampere, 4. Okay, we will get it by tomorrow. So basically, in today's session, we have done with the charges, done with the voltages, done with the power, and law of conservation of charge and law of conservation of energy. Thank you, class. We will meet soon in the next session of tomorrow. Is there any doubt to anyone? Is there any doubt?